Welcome to Demo Deep Dive. I'm basically Cedric's counterpart, and my name is Rohan Venkatram. I lead the Interactive Experiences program, and basically we work with the BUs to be able to create the content that you see on interact.redhat.com. So if you scan the QR code at the top left, you'll be able to follow along. And we're here with Nuno Martins. So Senior Principal Technical Marketing Manager for Ansible Automation Platform at Red Hat, obviously. And basically, Nuno's a Red Hat certified architect, and he's been with the industry and helping organizations for over 15 years to automate their infrastructure and their networking and their security. So all things security and very relevant to today's episode. So Nuno, you want to give us a quick intro on some of the stuff you're doing as a technical marketing manager? I'm sure you have a lot of different projects you work on, and one of them being this demo, but just Summit that just happened recently. I know there was a lot of content being created for that. So yeah, tell us more.
Yeah, sure. So firstly, thanks for having me on here. So basically, I mean, we obviously build samples and demos and use cases that we work with our customers. And a lot of the stuff that currently I'm focusing on is obviously security related. I tend to work on security, and I work on also like event-driven automation and event-driven Ansible. So yeah, even with Summit, I mean, we had obviously a good turnout. You know, we were talking about the new launch of the 2.7 version of Ansible, and basically how we have all these cool new features coming out, a lot of you know, messaging and guidance around, you know, bringing AI into the automation mix, and how Ansible can actually be kind of like the governing platform for this, right? So if you're going to be introducing agents, it's a safe way to automate with agents going forward. So that's really cool. It's really exciting. There's also been obviously a brand new kind of interest in security automation, which is great. It's great for me. And I mean, what I'll kind of go through in terms of these this demo here that you have, this is touching on kind of a mix kind of bag, right? Because we're talking about things like policy enforcement with Ansible. But this kind of leans very much towards like zero trust and zero trust architecture, which typically, you know, some people get kind of a bit afraid when they hear things like zero trust, because it can be quite complicated. But ultimately with Ansible, it kind of simplifies that process. And as you know, like, you know, in today's world, in terms of how things are going with, you know, threats internally as well as externally, zero trust is becoming more and more a kind of architecture that's almost a non-negotiable. And being able to automate that is obviously beneficial for all of us.
Yeah, definitely. I mean, first off, I guess to start things off, you talked about security and automation. And I think just for the people out there, so automation is powerful. But as you said, the security layer seems to be of interest to the field and people, potential customers, but just tech heads in general. But first off, what is Ansible Automation Platform, and what's the difference between that and Ansible itself, or just automation itself?
Yeah, sure. So, I mean, Ansible, if you go back to when Ansible came out, Ansible was a way of basically running all your tasks in what they call an Ansible playbook, right? So, you know, you would take things that you would typically do, and those would become modules. And inside those modules, we would use those modules inside of our playbooks to go and, you know, build out configurations, these types of things. And you would run a playbook against a number of hosts. Now that was pretty powerful, and that's all cool, but ultimately we want scale, and we want you know, more logical workflows, etc. And this is where Ansible Automation Platform actually comes in, because the platform itself offers all of this. Obviously, it offers things like you know, role-based access, etc. These typical things that you would get from a platform. But being able to automate at scale anyway, this is what Automation Platform brings, right? So it brings in the fact that we could run like an automation mesh that would allow us to basically put automation anywhere we need it. Bring things in like our obviously event driven. So, you know, event driven, listening to different event sources and being able to trigger remediation or trigger some kind of automated response. You know, something gets changed from a configuration perspective somewhere, we're able to know about it and obviously reinforce the configs from that perspective. So, outside of all of this, it's really about scale and giving us that, that efficiency in terms of being able to automate the same way over and over again, getting rid of all those human errors.
Yeah, no, that's great. And I think I'm looking forward to the demo itself. Just before we jump into it, if people have any questions for Nuno along this journey, please drop it in the chats. And you can explore our full catalog of demos. I mean, for Summit itself or in general, you're an active creator in the TMM community, right? The technical marketing managers. So you've created a lot of security-based Ansible or Ansible-based security demos, right? So this is one of them that we're going to be talking about today. So yeah, this is the catalog, interact.redhat.com. And yeah, should we just jump into it? I know there's some great stuff. Let's talk about multi-layered policy enforcement with the Ansible automation platform. And you talked about policy as code as well. So yeah, there we go. Go for it.
All right. So on this demo, basically, what we have is we're going to have basically a way to enforce what we call the policies. So typically what would happen is if you have what they call zero trust architecture, some of the key aspects of zero trust architecture is the fact you want to be able to control, who does what, how they do it, anything from, you might have a policy that updates or changes on infrastructure could only take place at 3 in the morning on a Thursday. All of this can be enforced with policies. So it goes really hard in terms of being able to give you that security posture. It's not a case of let's just go make changes or even just a change control. Change control is not necessarily good enough to kind of drive what you want to do. So if we go and dive into this here, firstly, we have to go and set this up. So from this perspective, we have, because it's multi-layered, we have a, outer ring and an inner ring. This is typically what we're going to be discussing. So the outer ring is always going to be the gated part of it. So think about being able to automate something. You would go and you would trigger some kind of job. And before that job actually triggers, it goes and verifies that it's actually allowed to do it. And this is what we typically call policy as code. So we would have to go set this up. So we would go and set up the execution side. And inside of the execution, you would see we have these settings for a policy server for OPA, which is kind of a standard. It's an open policy standard in terms of what people use for policies, right? So we would go and configure this. You would go and you'd set up, the host name, ports, any types of timeout requests, etc. You'd set all these settings up. Okay. Now, once we have all of that in place, you've now set up a server basically in the environment to look up for. The next thing we'd have to do is we actually have to tell the platform, okay, whenever we run something, you need to go and actually check with the system to make sure that there's a policy in place to kind of govern what we're trying to do. So this is kind of the next settings that we're going to do. We're going to go and we'll set it up in the organizations itself. So inside of the org, we would go and we'd change the setting. And you can see here a point for policy enforcement. So again, this is where we tell the platform, okay, if you want to check for policies, you need to check here on the server that we've just configured, right? So we would put in a policy in terms of where it needs to go check. So you can see here, there's AAP gateway decision area, right? This is the endpoint. And then from there, we go next. And now what we would do is we would simulate a scenario, because typically what would happen if you have something like zero trust in place is you would have IDM in place. So you'd have some kind of identity management. And the platform would kind of tie into that. So if you have to go and log in and you want to automate something, you would generally use the credentials and the accounts that are coming from that IDM. So now we're going to go and log in as another user. So we'll log in as an app dev user. And once we've logged in, you can see we have a job template here. We want to configure a VLAN, for example. So the user as an app dev, I'd be able to go in here and I'll say, cool, I want to run, I want to add a VLAN and I want to add a name, etc. into my switch configuration. And ultimately, you can go ahead and you can then make these changes. And when this job first executes, this is when we'll see the first policy enforcement. So when we trigger this, the first thing it does is says, okay, the job has to execute. And now it's going to use the settings that we had just configured. It's going to look at the endpoint, going to look at that OPA server and say, okay, I've got this user. He's trying to run this template and he's part of this team, et cetera, and it checks it with the policy. And normally what would happen is the OPA would then reply. So this is the reply we've just got. So you can see here, for example, that this user is not actually allowed to run this template. He's not part of the correct authorized team. He's app dev, he falls under applications, right? So therefore he can't make these changes, right? So immediately we already have an example where AAP has stopped something. And think about it from a bigger scope. You know, if we're talking about AI, this is going to be quite powerful because a lot of the times we've seen a lot of self-healing infrastructure where we take an issue with event-driven, it listens to the issue, it forwards it over to an LLM. The LLM can go and take out a response to tell you what that error is. That can get pushed to generative AI, and then you have some kind of remediation playbook. And you know that's cool, but if someone just goes and blindly, you know, runs that that playbook, it could be quite problematic. So if someone goes and just runs it, this is one way to secure that because policy could actually enforce and say, wait a minute, you're not actually allowed to be running this, or this is actually not allowed to be deployed without it being checked, etc. So you can get quite powerful from that policy perspective. Okay,
yeah. So there's a difference between identity and the authorization itself, right? There's layers to it.
Yes. So I mean, you know, you can. The thing is like this: you could be the right person, you could be in the right group of users, you could have the passwords even, but maybe you're not allowed to touch certain infrastructure, or maybe you're not allowed to alter infrastructure at a certain time of day. You know, this is where policy comes in and it really starts to narrow things down. And in this example, we'll actually even go further than policy, but you'll see that you can have all these controls based into your automation to ensure that the changes that are taking place are actually authorized, they're actually correct, it's the right people that are actually triggering it. So that's obviously really important because to have controls where you can log in and you have certain access to templates and then you can execute some automation, that's great. But we really need to be able to narrow down, you know, who has the ability to do what, and that's where policy comes in.
Yeah, makes sense.
Cool. So now I've logged in as another user, and I've logged in as a network engineer, for example. I'm going to run the same job. So in this demo, we would run the same job now. Previously, we were an app dev user, and now we've run this job as a network engineer, right? And remember, we're making network changes. Okay, so that's why that kind of works. So if we look here, we can see a lot of green. So green is good, but we can also see that the job actually failed. So let's have a look here in terms of what's going on. So firstly, you can see from these jobs that we had queries to OPA, and we had what we call a workload identity verification. This is something I'll tell you about in a few bits. So basically, when we ran it, the job is actually run. So the first thing is that OPA allowed this job to execute. So the policy said, cool, the network engineer user, he can run this, so he's good. So now the job executed, right? And we can see here that we have another OPA decision, okay? This decision, though, says it's been denied. So let me paint the picture for you a little bit. We've triggered it, that's been allowed. And this is where something called workload identification steps in. This is commonly known as SPIFFE. And in the zero trust world, what is this? This is workload identification, where they say, okay, maybe you're the right person. Maybe you're in the right team. Maybe you're at the right time of day, etc. All of these things are correct, but maybe you're still not allowed to make changes to certain infrastructure. So in this example, imagine I'm a network engineer and I'm trying to make a change to a VLAN, but I want to actually make a change to the VLAN on the core network, the core switches. So I would go and make this change and run this job. And again, I'm part of the network team. I'm a network engineer. All these things are correct. But what happens is with SPIFFE is I go and get an identity, basically an identity key from a SPIRE server. And the SPIRE server says, okay, on the automation platform, this is your identity. When I try now and say, okay, I'm going to actually automate with the automation platform, the OPA policy checks, okay, this platform is actually not allowed to make any changes to the core network, because the core network should only be changed by actual network administrators or higher level people, on keyboards, for example, to make those changes. We don't want any automated action on the core. And this is where this is now stepped in. So it says, cool, you can run the job. Here's your ID. And then the last OPA check is, okay, this ID is actually not allowed to make any changes on that core because it's not allowed to be automated. Another thing could be an example where maybe you may be automating instances in the cloud or infrastructure in the cloud, and perhaps your production infrastructure, you want to make sure that that production infrastructure doesn't get changed by network engineers. You have to have a higher level of authority, and maybe there's even a very specific execution node from an automation perspective that only is allowed to automate in the cloud. These are the types of restrictions that you can start to build when we start to build out the multi-layer example. Okay, all right, so now from this, it's just going through now the SPIFFE SPIRE IDs, and ultimately we will have now the last example. And the last example basically is, okay, well, we're the right person, we're in the right team, we're at the right time, and the actual automation itself is allowed. So we log in as a network admin. So now we obviously are higher level, and we want to go and execute the job. So remember, if you've noticed, we're running the same job all the time. Nothing changes on the job. But because of the accounts we are using and because of the policies that we are using, we're able to enforce different permissions and different allowances for each team and each person. So I would go then now as a network admin, and I'd run this, and basically we now are successful, right? Because OPA first checks to say, cool, this is a high level individual, they're allowed to run this job. The SPIFFE check, or the identity verification check on the workload, came back correct. And then ultimately OPA checks that identity to make sure that that identity is correct. And all of these things have fallen into place, and we now have multi-policy enforcement. So we've been able to really narrow it down to only network admins who are actually allowed to make changes to these specific switches. So yeah, that's basically the multi-layered policy and how we can use this to really control, from an Ansible perspective, the changes that can take place on the infrastructure.
Yeah, perfect. I mean, honestly, a lot of new words and concepts, but I think it makes sense. I mean, I think having those guardrails in place just to ensure that people aren't able to access everything and anything depending on your role completely makes sense. I mean, one security check isn't enough, right?
Yeah.
Just a question about the OPA itself. Where does Ansible automation platform make the decision, and where does OPA make the decision?
So basically what happens is OPA runs on a separate environment, right? It's a separate server. And when we query with OPA, we actually pass the metadata and the context over to OPA. And based on the policies that have been written and in place, that will give some kind of decision which actually goes back to Ansible. And from there, it decides, either the job gets stopped, et cetera, or we carry on. What's key here is we have policy as code. So policy as code is built into the platform where we can query the OPA when we execute. But you start to really get additional power in what you're trying to do when you introduce the policy check-in into the automation workflows themselves. So, I mean, we don't have it here, but normally what happens with automation is you build a logical workflow where you can do multiple things on different environments and orchestrate all of this, etc., so that you have a workflow of automation. It's not just you automate one system. You're automating that system plus the network, plus the firewall, plus you're putting all that information into a service ticket, etc. You start to orchestrate all this stuff together. And part of that is frequent API requests back to OPA to say, hey, are we allowed to do this? Can we do this, etc. And OPA just looks at the policies that are normally built and set by the InfoSec team, the security team, and applies that logic, applies that governance into what you're trying to do from automation. So if the security team decides that no changes will take place on a Friday, you can try run as many automation jobs as you want, but nothing will take place on a Friday because that policy will step in. Which is good because it means that at least it also helps the security team. Sometimes we automate and we almost automate on an island because, it's like, what do you want to automate? I'll automate it. I'll automate it. You take all these use cases, you start to build it. And if you're actually working with InfoSec, they get comfortable because they now know that they can enforce their controls that they need. Because remember, InfoSec is also not just about control. InfoSec is about governance. It's about compliance. One small change could actually cost the company a lot more in terms of revenue, security, et cetera, et cetera. So it's important to work with InfoSec. And this is one way that we can work quite closely with them to automate what we need to automate.
Yeah, definitely. And so for those people trying to scale or just even trying to implement this, for teams new to OPA, like how difficult is it for them to start writing policies? Like, what is the language that we're talking about here?
Yeah, look, these are REGO policies, and traditionally they have been quite tricky to get going. But I mean, to be honest with you, that whole ceiling has kind of dropped because obviously we have AI now. There's so many references to build out. It's not as tricky as it used to be. But ultimately, the framework, I mean, the OPA server that gets deployed, you could use Ansible to also deploy the policies into it. So Ansible starts to help the OPA stuff as well. You can get Ansible to deploy OPA, get it to deploy your policies sitting from a Git repository, etc., and then just integrate the two tools. But yeah, I mean, going back to the original question, yes, you have to build REGO policies. They have been tricky, but I really think that whole barrier has come down now because, you can quickly go and take a couple of samples. You could reference AI, say, hey, I want to do this, 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 read through it, go through it, make sure that it makes sense in terms of what you want to do, and then obviously test it. I mean, again, you're just looking up a policy. It doesn't affect anything. So yeah, that's become a lot easier, and it's also standard. It's a standard. It's not like you creating something that just only we use from an Ansible perspective. This is a global security standard in terms of policy. So it's not that tricky anymore.
Yeah, I mean, I'm glad you mentioned AI as well. I mean, now with AI, if AI starts recommending or triggering actions, how do we just make sure that automation still stays governed and trusted with this?
Yeah, look, I mean, that is one of the real benefits around Ansible because, the platform itself has a lot of controls already. We've had controls around for a long time because why? We have multiple teams of infrastructure people, DevSec people, DevOps people, all working with this automation platform. And we've built all of these controls in terms of things like role-based access, etc. Bringing an AI into this is where, this is kind of where we see things going. We're able to still bring all of that control and governance, etc. And if you think a lot about the typical use cases that we have, from a security, we have foundational security use cases where we trigger things like compliance and hardening at scale. Being able to go in there, and if you drive all of your changes in your infrastructure through automation, you have a full audit trail, who did what, when it happened. If you're using policies, we have a way to enforce policy. But you always have things like event-driven, which is also still there. And event-driven is listening to your intelligence sources. It's listening to your monitoring systems. It's listening to your cloud buses, all these things. And any type of change that takes place at any time could ultimately be a trigger for event-driven. So, ultimately, when I talk to customers and say, okay, well, maybe if you have event-driven listening to your observability platform, someone goes and makes a change, you can always trigger a template to reinforce compliance, reinforce hardening, and even revert changes if you needed to. I mean, think of a change where if you only automating your infrastructure and you're using like a source of truth to do that, a single set of playbooks, et cetera, et cetera. If someone goes and just logs into a system and makes a change, immediately event-driven can kick in and redeploy the config that it should actually be in place to make sure that you have organizational compliance in place. And then at the same time, it could automatically open up a service ticket to say, hey, there was a change on this system at this time. This was the user that was logged in, et cetera, et cetera. and you can start to curtail that, right? You can obviously start to say, okay, we need to harden systems down. We need to reduce the risk from people being to, log in, etc. Start taking principles like defense in depth, and automate that, obviously. So there's so many things around security and AI. It's not just about patching. It's not just about fixing the quick change. It's about making sure that you're able to make sure that you have that security posture at all times. The fact that you can change security posture at scale quickly, and you can mitigate and contain environments when there's an issue, when there's a vulnerability, we don't have a fix, for example.
Yeah, no, makes sense. I really see the value of layered enforcement. I mean, especially now with teams trying to scale with AI in mind as well. Thanks for summarizing that. Do you mind just quickly, I guess we have gone through it, but just in those steps, summarizing the multi-layered security model for the people at home as a soundbite? Just those
Yeah, sure.
steps.
Yeah, so I mean, multi-layered policy enforcement with Ansible, we're talking about two main things. We're talking about almost like a gated policy enforcement with an outer ring. So this would be our typical policy as code. So if you execute a job, before it executes, the platform itself checks with the policy server to say, is this individual allowed to automate? Is this person in this group allowed to automate? Can they run this job at the moment, et cetera, et cetera? And if that policy says no, it gets denied before it even executes. Then the secondary layer internally is, if that person is actually allowed to automate and they trigger that job, we can have multiple layers of policy checks throughout our automation to say, hey, we're about to make changes to this infrastructure. Am I allowed to do it? Is my group allowed to do it? Is it the best time to do it, etc.? Some companies have certain windows where we need to make changes. All this can be driven by a policy. And lastly, once you've gone through policy checks, we still have things like SPIFFE that we can introduce, where if I'm going to automate something, I can actually get a SPIFFE ID, which gets generated. And that SPIFFE ID can then go through into a policy check to say, hey, can this user specifically make changes to this infrastructure? And where it's slightly different is, policy enforces based on accounts. But you might actually have infrastructure. If you think about Ansible itself, Ansible runs on infrastructure. Ansible runs on systems. And maybe those systems that are on there shouldn't be allowed to make changes to certain infrastructure. So this is a way that we can kind of curtail that by using something like SPIFFE. So yeah, those multi-policies, multiple checks all the way through as we're driving automation to make sure that the stuff that gets automated the right way at the right time by the right people, all through authorization, all through identity management. So we have that chain of custody, and we have least privileges throughout when we're trying to automate.
Thanks for summarizing that really well. And for everyone else at home as well, you can do the demo yourself in the top left if you scan that QR code. And as we mentioned, we have a full repository of these demos on interact.redhat.com. There is a question in the chat, Nuno, if you're seeing that. Do you think it's something we can answer at this time?
Just see it. I can't see the question, so can you tell me what the question is?
It's to do with RHCSA. It might not be relevant to this topic.
No, that's fine. We can still discuss it. I see it now. So the RHCSA, that's the System Administrator Certification. That's driving towards an RHCE. Is it still a good path? You kind of want to learn, or you're doing the Kubernetes cloud, et cetera, et cetera. So I can tell you straight away, as someone who's gone through this, and we've gone through all the way from the CSA all the way to RHCA at architect status, it definitely is worth that path. More and more people are interested, obviously, on a Red Hat Certified Engineer certification. That's kind of gold standard in terms of proving to potential employers, etc., and what you're trying to get into, etc. That's a really top class gold standard. If you want to dive further than that, that's where you can go into specialties, like you mentioned, things like the Kubernetes, etc. Obviously, from our side, things like OpenShift, there's so many certifications that we can go through specifically for OpenShift, which are specialties. And that will obviously build up to being a Red Hat certified architect. For me, I think one of the most important certifications you can get if you are in the Linux space is a Red Hat certified engineer. So for me, it's definitely worth it. If you have to go through that process of certification, get the good stuff, get the RHC SA, that's your system admin status, and then push through to get to RH CE, the certified engineer. And from there, then you can decide what you want to do. But those are really, really important certs in the market.
Perfect. Thanks so much. And so I guess as a next step, you've looked into the policies and setting up policy like administration and authorization and through OPA with Ansible automation. What's the next step? And in the sense of, you've been working on a lot of interactive demos. Are there others that you recommend doing after this one?
Yeah, look, we've got so many, which all have value. From my side, obviously from a security side, apart from things like multi-policy, there's also ones where we show Ansible as a policy enforcement point inside of Zero Trust. So these are very heavy security topics, right? But we also have things like where event-driven could be used in AI ops, or event-driven is used for incident response. So perhaps it detects a brute force attack on your infrastructure. What could we do typically to contain that threat? Otherwise, yes, the AI ops stuff is really good, where we can reference errors, we can enrich those errors. A lot of the times, most useful use cases are always going to be information-based. So if you can have a use case where we can go and get some kind of error, ask AI to define it for us, give us a little bit more information, maybe even some recommendations. Those recommendations we can then use to remediate. That's pretty powerful. That cuts a lot of time out from troubleshooting and escalation, etc. So we have those as well as arcades. Those are great. Any of the cloud arcades are good. Cloud arcades are always important. We want to be able to automate multiple clouds. We want to be able to drive compliance across all of those, provision, deprovision. And obviously we have some really good HashiCorp stuff where we integrate with Terraform and with HashiCorp Vault. So there's plenty of stuff there in terms of those. If I was going to do it, the first thing I would do is go have a look at the AI ops stuff. Then have a look at the security. If security interests me, and definitely the cloud stack. That's quite cool.
Perfect. Well, thanks so much for chatting with us today. Basically, as I mentioned, interact.redhat.com is where you can find those other demos that Nuno was talking about. And everyone, thank you for joining this episode. Just any leaving notes for us, Nuno? I know as a technical marketing manager, you can be found on, you have your own author page with your contents, blogs, and things like that. Any buzzing topics in the market and the field today, and anything that you're working on that's super interesting that you'd like to share?
Yeah, look, for me, as I mentioned, security right now is a key focus. There's a lot of focus at the moment around things like the AI threat. So, we've all seen things from Mythos and other frontier models and how that's going to impact the way that we move forward. And for us, from an automation perspective, if you have something that's generating attacks, etc., at machine speed, you kind of need mitigation and containment at machine speed too. And that's what Ansible can do. So this is something we've started exploring. We're starting to build a lot of content, use cases, demos, etc. So that's going to be really cool. I think that's going to be super interesting to get out. And it's a natural thing for Ansible, right? It's a natural thing where we can detect certain things and try and mitigate that using standard security protocols, methodologies, and automate all of that. So that's going to be cool.
Definitely. And I think you have answered a lot of people's questions today as to the next steps for them as well in if you are or aren't a Red Hat customer already, but also looking for ways to automate your platform and integrate within OpenShift and other open source technologies, more to come. And as the geopolitical situation changes as well, and just the AI space changes, stay up to date with some of the content we have today. Well, thank you for joining us today. And this was a demo deep dive. Thank you everyone for joining this episode. We'll be back in 2 weeks with Cedric as well, and we'll explore further topics. If you do have other topics in mind that you'd want us to cover and demos that you'd want us to dive into, leave us a comment, like, subscribe, Venmo us. No, that's not on us. But and catch you in the next episode. See ya.